OZKi-Bot is a sample application that demonstrates 3 use cases of the OZKi Toolkit. To begin, we will demonstrate proof of payment with PayPal. After clicking on the PayPal icon, the user will be provided with the option to purchase a subscription. They will be prompted with PayPal's standard subscription dialog. Once the payment is completed, the user will be given a billing ID, which will be used for future access to the application. This will be shown in our next example. While we are waiting for it to load, I'd like to point out that there is no sign-in or login button on the main page. This is by design, as OZKi-Bot uses the Get Proof flow as a replacement for sign-in. A big kudos to those of you who noticed this. Our next example is proof of payment with PayPal subscription billing ID. In this case, an existing user who has already paid the subscription would like to access the application. The user only needs to enter the billing ID to get the proof. While we wait, here's an OZKi fun fact. OZKi does not require any data to be stored. The proof verifier validates the cryptographically generated proof value to validate a user and determine whether or not they should be granted access to an application or certain resources. This sequence diagram illustrates the interactions between the browser, server, Oracle, and PayPal server. The key takeaway here is that the only data that flows from the browser to the server is the proof, meaning that no PII data is ever sent to the server. Next, we will demonstrate proof of login with Google. To get started, we will click the Google icon. The Google login is then displayed. In this first attempt, we will use a non-Berkeley email. Because the user has not entered a berkeley.edu email, they are not granted access, which is noted in the error. This is to be expected since we did not use a berkeley.edu account. That was demonstrating a negative case. Next, we will demonstrate a positive case by entering a valid Berkeley email. After successfully logging into our Berkeley account, we are verified and granted access to the game. Time for another OZKi fun fact. OZKi Proving System has the concept of Proof Time to Live, or TTL. This is an important security feature which is used to determine the age of a proof. This call sequence diagram illustrates the interactions between the browser, the OZKi-Bot server, the OZKi Oracle, and Google. This diagram shows that the only information that flows from the user is the proof. Next, we have our fourth and last concept of this demo, proof of hash. The OZKi-Bot game was designed using Unity. The concept of the game is that the user provides a nickname and proceeds to solve the puzzle in order to win the game. The user plays as a robot character to search the room for clues that will help them determine the correct pin needed to open the door. When the user inputs the correct pin, they will receive a score that will be added to the leaderboard. Because the leaderboard does not know the correct answer to the quiz, it needs to be able to verify the user's answer is correct. This case is solved through using the OZKi proof function, which calculates the hash of the answer. The leaderboard only knows the hash value and does not at any point know the user's answer. This call sequence illustrates these interactions. Time to share one last fun fact. OZKi is open source.